Okay, this is the segments and midpoint video. First thing, let's define what a segment is. Segment is basically object has two endpoints, no arrowheads, and it is named by two endpoints with segment notation above. As you will see as we're going on here, when we're talking about the length of a segment, there's no notation above. So looking at this measuring segments, the distance between 2 points, A and B, is written as the length of the segment. Okay, and it's indicated by no notation above the two endpoints. So the length of this segment, if we counted, is 4. If I have two measurements of segments that are the same, so if AB, the length of AB equals the length of CD, then this is written as the segments are congruent. And that little symbol there is a equal sign with a what I call a little squiggly above it. Equal sign with a little squiggly. Okay, you will also see when we say that the segments are congruent, I'm going to draw another picture here. If we do this, and I'm just going to draw them as two separate, you will also see that we will put these little tick marks, and that indicates congruency. All right. Segment addition postulate. So I have this collinear points, right? Collinear on the same line. B, segment or point B is between A and C. Then I can say that the length of AB plus the length of BC equals AC. We're going to use that to complete some examples. So first thing we're going to do is we're going to write down our segment addition that pertains to that diagram. So this diagram, I have PQ plus QR equals PR. And then we're just going to substitute in what we're given. So I can see in number 1 it says PQ is 9 and QR is 28. We're trying to find PR. We add those together. I get 37. In example 2, I'm trying to find PQ, one of the shorter segments. So PQ plus QR equals PR. So when I'm trying to find one of the smaller ones, I'm going to subtract. So PQ equals 4. Now let's try some that are a little bit more involved with some algebra. We have to make sure that we pay attention to what it's asking for. This is just asking for the value of x. So write our segment addition, EF plus FG equals EG. Substitute in our parts. EF is 8x minus 17. FG is 5x minus 3. And EG is 71. Combine like terms. Combine like terms. Combine our variables. Combine our constants. And solve. Divide by 13. X equals 7. So I'd like you to go ahead, stop the video, and try number 6, because number 6 is going to be very similar. Very similar as far as what you're trying to find. You're only trying to find the value of x. So the first thing you need to make sure that you do is write your segment addition. Substitute in x plus 3 in place of CD. 8x minus 9 in place of DE. And just so happens we have an expression for CE this time. Combine. 3 plus negative 9 is negative 6. Subtract 7x from both sides. Add 6 to both sides. Divide by 2. Let that digest. Look at them again. We're going to try the other two. Okay, so now let's look at the next type of problem. The next type of problem we need to look, it says find TU. So this time we're going to go beyond just solving for x. So again, let's write down our segment addition postulate. It says that TU plus UV equals TV. Substitute in, TU is 9x plus 2, UV is 5, TV is 14x minus 8. This is just solving an equation now. Combine like terms, 2 plus 5 is 7. Subtract 14x from both sides. Subtract 7 from both sides. Negative 8 minus 7 is negative 15. Divide by negative 5. So I get x equals 3. But again, that's not what I'm trying to find this time. This time I'm trying to find TU. So I need to substitute in to that expression. What is the expression for TU? It's 9x plus 2. So I take 9 times x, which was 3, plus 2. So TU equals 27 plus 2, which equals 29. Okay, number 5 is the same type of problem. Again, I'm trying to find an actual length. So I need to find x first, then substitute in. So what is my segment addition? It's JK plus KL equals JL. Substitute in that first. 27 plus 3x minus 1 equals 5x plus 2. Combine like terms. So I have 3x, 27 minus 1. I would just move x's to the left. Does not matter which one you could always subtract 3x from both sides instead. Then subtract 26. And divide by negative 2. So you get x equals 12. But again, that's not what it's asking for. It's asking for JL. And what is the expression for JL? It's up top here. JL, the expression is 5x plus 2. So JL equals 5 times what x is, which was 12, plus 2. 5 times 12 is 60. So JL equals 62. Okay, on the next page, we have one more example, this segment addition. Okay, part 2 of our segments video is going to just highlight midpoints and another topic dealing with midpoints, bisector. So the first thing we want to do is define what a midpoint is. The midpoint of a segment is a point that divides our segment into two congruent segments. So if I know, looking at this diagram over here, that AC, segment AC, has a midpoint of B, it divides it into two congruent segments. And we can mark those with those little tick marks. And I furthermore know then that AB is congruent to BC. Okay? A line, array, or a segment that intersects another segment at its midpoint. Okay? So that is this right here. This happens to be a line. Okay? It's going through the midpoint. It's going through the midpoint. So that is called, well, first off, it's said to bisect that segment if it goes through the midpoint. And then it is called a segment bisector. So in this diagram, B is the midpoint of segment AC, and line L, I kind of wrote over it there a little bit, but line L is a segment bisector of that segment. Okay, that's really all there is about midpoints, so we're going to do some examples. So I'm told that Q is the midpoint of PR. So since I know it's a midpoint, I know these two segments must be congruent or their lengths equal. Their lengths are equal. So I can say 7x minus 16 equals 4x plus 2. Subtract 4x. Add 16. It's an equal sign up there. Divide by 3. And I am only looking for the value of x for this first problem. Okay, so let's look at the next one. This time, though, I'm to find a length. This time I'm trying to find a length. So again, H is the midpoint, so I know these two are congruent. When I'm told it's a midpoint, they're congruent. So I know that GH equals HI. So 5x plus 2 equals 9x minus 10. Subtract 9x. Subtract 2. Remember, numbers on one side, variables on the other. Divide by negative 4. So I get x equals 3. But remember, it wants to know GH. So GH, we substitute our x in, so it's 5 times what our x is, 3, plus 2 equals 17. Okay, let's look at the next one. QR, or R is the midpoint of QS, so I know that QR equals RS. The first step is to find x, so we set them equal 2x plus 16 equals 5x minus 17. Subtract 16. Divide by negative 3. But this time, what's it want me to find? This time it wants me to find QS. Okay, so how do I find that? Well, first thing I would do is substitute into one of the two expressions. So let's find QR. 2 times 11 plus 16 equals 22 plus 16, which is 38. And I know QS equals QR. Or I'm sorry, RS, my bad. I apologize for that. Let me write this again. Sorry. I know RS equals the same thing, right? Because we wrote that down at the very beginning. R is a midpoint, so QR must equal RS. And to find QS, I just add those two together. Segment addition. QR plus RS equals QS. And the last one is a little bit challenging. Let's first see what it's saying. It's saying that G is a midpoint, so those two are congruent. And it's giving a different expression for the whole length. So the first thing we're going to do is let's find our x. We know those two are congruent. So let's find our x. Subtract 3. Divide by -3. Okay, let's find FG. Four times 5 plus 3 equals 23. And I know GH equals 23. So to do FH and find Y, we know FG plus GH equals FH. So I know 23 plus 23 equals 6y minus 2. I'm just going to leave my y on that side, since I can just isolate it by adding 2 to both sides. And then divide by 6. So this one was just a little bit different, and hopefully you were able to understand that. And this ends our notes on segments. So now you want to go back to that assignment that we were working on and finish out those problems 10 through 15 that deal with midpoints.